see about the how the physical connection exists between the input output device and memory. Okay, we will study more detail about it. Physical connection. Okay, how it is actually connected. Physical. Okay. So processor has to communicate with input output devices, and it at the same time it also has to communicate with the memory. Okay, so in order to get the memory, so three things required actually for the processor to do anything. Actually three things. What? It should specify the address from, for example, memory. You take the memory from which there are multiple, take thousands of houses like that, so there are multiple memory locations, from which location it has to fetch. So it should contain address. Okay, then from that particular address location it has to fetch data. So then data address bus. I'll explain what is bus. Data bus. Next, control bus. Okay, what does it mean? We'll study this. What does bus means? Bus means is nothing but set up parallel wires. For example, 8-bit bus. Means 8 wires will be there. So this is a bus. Okay, that means parallelly 8 bits can be transferred either. For example, 8-bit bus means, for example, 8-bit memory. 8-bit bus means 8 wires can be 8-bit can be parallelly transferred to the processor. Okay, like that, 16-bit, 32-bit, 64-bit. So more the number of bits, more the data can be transferred at a time. Okay, it isn't like this. So 8-bit means 18 parallel wires, just like 8 parallel wire connections at a time. Instead of just single wire, it is like 8 wires parallelly, 8 bits it is transmitting. Okay, so at a time 8 bits will be transferred from memory to processor, like that. If it is 16-bit bus means 16 bits will be transferred at a time. Okay, so bus is nothing but a parallel number of bits it can transfer. Okay, so next, what does in memory location, to transfer memory location, it should specify the address. So address bus. So what does MAB means? Memory address bus. Okay, from which location? Address bus means address, which location it has to get the data. So it should place the, first it should send the memory address. Okay, then what should it place? Control signals. Control bus is nothing but read, write, like that. Read like means it is nothing but first it should place the location. So memory will select the particular location. Okay, then it should know, the memory should know, it should give the data to the processor, or it should take the data from the processor. So read or write. For example, if it is read operation, control signal will be the read signal will be highlighted and memory address location will be highlighted. So from that location data will be placed in the data bus. Okay, that particular location will be selected, and if it is read operation, data will be placed on the data bus. Data bus means, data means parallel wires, you understand. So for example, memories contains something like this, you assume like this. Okay, roughly you assume. For example, there is address points to this location, some location. Okay, so it is read operation. What will happen? This will take the data from this one and place it in the data bus, and it will be transferred. So this is memory address bus, data bus, control bus. This is for the memory. Like that, input also, input output devices also, like this is also peripheral to the memories, actually peripheral to the processor. So input also, data address bus. Data address bus means DAB. Data address bus means from which input output device it has to get the data, and control signals, it has to read or write. Okay, it has to take like, and data bus, and data means corresponding data, same like this one, just nomenclature is different. But here you have to note that the processor works in extremely fast. I already told you actually in the previous class. For example, it is runs at speed of 1000 times. Okay, it runs 100 times. It is just 10 times. That means if it is runs at input output device runs at 10 times. Okay, 1000 times, sorry, like this. For example, input output takes, for example, processor takes thousands. That means there is a lot of difference. this is much faster. Okay, this is slower, this is little bit slower, this is 10 times slower, 10 times slower, 10 times slower than roughly I am saying. This is much faster, this is moderate, this is extremely slow. When compare relatively, we compare these things. Okay, this works in nanoseconds. So memory is 10 times slower. Okay, this is 1000 times slower. I already told you. Okay, roughly I am doing. So reading from the memory, when compared to reading from the memory, when reading from the input output is, it takes lot of time and it make the processor in the wait state actually. Okay, so this is the address bus, this is the physical connection, how it will connect. So here what are the terms you learn? Data bus. Bus means connection of parallel wise, and in order to communicate between any processor or input output or memory, it should contain three things: memory address bus, data bus, and control bus. So these three operations will do. So this way, for example, programmed. Now you take this. So if the processor is connected in this way, and if the processor reads directly from the memory, and at the same time it reads directly from the input output, for the processor it will take longer time to the processor, because input output reading is very time taking actually. So it will waste lot of processor time. This way, this type of connection is that programmed input output reading. This is programmed. This is like directly processor involving and reading from the input output is called programmed input output device reading. Programmed reading, input output reading. This wastes lot of processor power because it takes lot of time to read. Okay, so in order to simplify this process, so there is one more method of transferring data from input output device to memory. Because in this process, what will happen? First, processor will read the data from the input output device. It will read to the internal register of the processors. Okay, but you know, processor registers is very temporary data. It is less memory, so it doesn't store any data permanently in the inside the processor. So what will happen? So it will read the data from the input device to processor. From processor, it will store it in the memory. So from the input output device, it goes to the memory. Okay, ultimately. So it is a very slow process. So in order to, this is one way of transferring data. In order to reduce the efficiency in this process, there is one more method of reading the data from the processor, that is DMA controller. Using DMA controller. Earlier we have seen that input output device directly connecting to the processor, like processor, memory, input output device. Okay, this is earlier case. In earlier case, what happens? Processor reads the data from the input output device and it stores in the memory. Okay, but in this process, it takes a lot of time of the processor and it wastes a lot of processor resources, because reading from the input, there is a lot of speed mismatch between processor and input output, because input output device is 1000 times slower than the processor. Okay, there is speed mismatch, so that this program driven data transfer from the input output is very time consuming, and exclusively it wastes a lot of resources. So instead of this connection, single bus connection, there is in order to avoid that, there is a two bus connection. What will happen? There is see here, processor and memory are directly connected. Okay, input output device, instead of transferring data like earlier, processor, memory, earlier what happens? This is the connection, this is the type of connection, you know. So processor reads from the input output data from the input output, and again from the processor it stores in the memory. Okay, in this process processor is involved, so that it wastes a lot of time and its resources. Okay, instead of this, what will happen? It is, instead of this single bus system, it is a double bus system. Okay, double bus system. See, processor is directly connected to the memory like earlier. Okay, but input output device, instead of directly connecting to the processor like earlier, what will happen? It is connected to the this bus is single bus is split into two buses like processor bus, and it is connected to DMA unit. DMA, this is important. This is also small logic processor, okay, direct memory unit, okay. This is the logical interface. What will happen? Processor will place the input output device address and location in this. It will in the direct memory access. So it will give the command to the direct memory access to read from this particular input output device. So address will be placed here via this process. So what will do this device will read the data from the input output device. It will read and it will store from here. It will directly store to the memory. So what will happen in this way? It is skipping the processor. It is which wastes the earlier scheme of transferring via processor is wasting of the processor resource. Now it is directly transferring from the input output device to memory. So just processor what will do? It will give the command to store or read whatever commands. It will just give the commands to the DMA unit and DMA will do the rest of the thing. But earlier thing what will happen? Processor will give the command and it will also involve in the transfer process also. It will wait till the data is ready and it will get the data and again it will store to the memory. But in this case it won't do like that. It just give the data address of the input output device from this bus and it will give the instruction to the DMA unit. So now DMA will do the rest of transfer, directly transferring to the memory, so that processor time will not be wasted. Earlier we have seen that 2-bus system, so that using DMA controller. This is also similar to that, but instead of 2-bus system we are just using a single bus. This is a single bus. Bus means set of wires, okay, you understand. Data bus, control bus and memory address bus, okay. For the single bus, memory is connected, processor is connected, controller is connected. Controller is nothing but input output controller, okay. So what will happen in this process? Actually this is used in the earlier personal computers, okay. So what will happen? This single bus system, instead of 2-bus, single bus will be there. So what will happen? The data transfer will take between any two. See, the data transfer will be transfer between any two, like processor to memory. For example, if the processor to memory transfer is taking place, so input output device doesn't use this bus, okay. Similarly, when there is a data transfer from this controller via input output to this, like this, from the input output controller to memory transfer, data transfer takes, processor won't use. So here it means that at a time the data can be transferred between any two devices, okay, either input output controller to direct processor or between processor and memory or controller to memory. Only these things at a time. Only two things can communicate via bus. Remaining has to be idle while one is transferred. So usually that input output control the priority will be given by bus arbitration unit will be there. That will give which one has to take the preference, processor to memory or memory to input output device, okay. Usually input output device will get the more priority because, for example, when input output device like reading from the hard disk, it is very slow and we can't change it to the speed. I mean, we can't change it to the disk location immediately when compared to processor, because input output is a motor based operation. It will go to the track and reach the data. Suddenly if you stop this and gives to the priority to this one, it again has to go to that particular location. It will be a lot of headache actually. So that usually input output device will give the preference than the processor, okay. Here you have to remember, in unibus system there is only one bus and the transfer of data can take place at a time between only between any two devices at a time, either processor to memory or input output controller to memory, okay. This input output controller of the input output is nothing but DMA control like thing only, it's nothing new, okay.